Huang, and this is the Milestone 2 demo for our GolfCoach-AI project. And here are my teammates.
Hi, I'm Fei.
Yeah, I'm Chipom.
So in this milestone, our goal is to build an end-to-end flow between the backend and the Android app. And me and my teammates Fei Huang work together uh, to do this step. So um, in this milestone, the users can register and log in through a real backend with the MySQL database. And after logging in, they can go to a video upload and preview screen. Um, Later, this flow will extend it with the AI, swing analysis, and reinforcement learning based coaching. But in this milestone two, we focus on the login and video preview part. And first, let me introduce the backend. So we use Fast API together with Circle Alchemy and MySQL database. And in this database, there are two main tables: the users table and the videos table. The users table stores the user's email and password, and the videos table store the title, the file path, and owner ID for each swim video, like we did in Milestone 1. On top of that, we implement the several APIs, like the
and phase. So we built the the biomechanical features factors for that phase. So it will actually the height disability this stability space and some elbow factors or elbow angles and so on. So each feature is normalized by the rough scale and clip to a reasonable range. So we typically specify in from the -3 to +3. And then we have the phase one hot. So it will return three-dimensional vectors. So this tells the policy which part of the swing that the state is describing. And then we have some like progress features for the special the RL. And we define a set of progress level features like the section um, section step normal. So it will normalize the step index within the practice section. And some section we caught can help us to get the best swing score so far in the section and to run in the average of scores. And also to calculate the difference between the current score and the previous one. So, but right now they are so in stage B they are typically will return zeros, but in the stage C, the LL environment will fill them with the real values to reflect how the player is improving over time. So, and all of this is combined in the build state vectors. So the and let me mention the final the LL stage is at given phase is called like stage equal like normalized features with plus the phase one hot and plus the progress features. So uh, so this is the return. And also this the helper function called the get state dimension that will return the dimensionality of the vector. So which we will use when defining the gym observation space in stage C. So so um so in this file we decoupled two parts. So the stage B is the biomechanisms and scoring, and stage C is the sequential decision making. Also, and then let me introduce the stage C. So it's all in the RL core. So in here we want to build in a full reinforcement learning environment. We want to turn the static analysis pipeline into the trainable reinforcement learning environment. So right now it has four main components. The action space, which is action.py, and the stimulated user's response. And the RL reward functions is here. Um, and the environment. We're still in the test, so we want to use the gym to test first. So let me introduce the action.py first. So in this function, we defined a more interpretable discrete action space. So each action is one of coaching advice the agent can give. So for example, like the coach will told you that keep your head more stable throughout the swing, or create some more separation between your shoulders and hips at the top. So each action is represented at the uh, specific actions stacked with integer ID and a human readable text string and a feature effect dictionary specified which biomechanics features this device is supposed to influence and can gather the play or direction. So we have a text function here. So like we have the when the agent will reply like to if the feature effect like look like this, maybe the agent will tell you like try to keep your head more stable and throughout the swing. Also, like if your hand height is too low, he will like to oh it's too high, so he will told you to lower your hand slightly at impact for more connected strike. Um, this this is mapping and we will mapping this later use the simulator to update when the certain device is choice. And also we have the simulator.py. So uh, and for now, because we don't yet have large amount of real users trajectories, so we want to build rule-based simulators in simulate.py to approximate the dynamics. And the core function is the simulate next AGG. Um, so it takes the current aggregate features and the action and return a new set aggregate features represented in next swing. So the key idea here is that for each features and phase, it looks like the target value from the scoring module and the action's intended direction, and then also the fixed specific weight uh, for example, like the egg top or the hand height many at impact. No, then it will move the feature slightly toward to the target in the appropriate direction, and with some random noise to simulate humans' variabilities. And finally, the it clips features to biomechanisms reasonable ranges. So this gives us a simple yet consistent mobile model, like how golfers we might change up the following each advice. And also, it's the RF reward.py. So this rewards for the agents, and all the reward computations is defined in these files. So we use the stage B scoring, which is the reward.py, and to define new functions um, in the for the agent. So mainly we the main turn is improving it's the improvement in total biomechanical score between swings. So we add shaping that. So if the reward moving toward the target for the features, so maybe which prove that the chosen action is supposed to be a fact. And then otherwise we will like penalize the reasonable like overly large jumps in features. Well, this makes the reward signal both aligned with the biomechanisms and sensitive to choice advice. And also we arrive like the environment top here wise. So finally, so the environment top here is tied everything together into the gym compatible environment cards. And the we so right now I'm still debug with this, but I can briefly to introduce this. So the observation is built via the build state vectors. So it includes that, the features, phase one heart, and the progress statistics. And the action is the discrete action ID from our action space. So and then the transition will use the simulate section step um, to from the simulator to produce the next swing features. And then the rewards will use the compute improvement reward from the IL reward.py. So the episode corresponds to one practice section and consisting of multiple swings for a single user. And then with the progress features updates at each step. I hope this environment can be plugged directly into standard RL library and such as stable baseline 3, and we can train the policy using the PPO or other algorithms. This is our my milestone 2. So in the next milestones, I will start hopefully I can start training policy in this environment and analyze the learned behaviors and later connect to the real users so that the GolfCoach AI can adapt to each player. Thank you.